How's it, grade 9s? We're going to be continuing with congruent triangles. Today we're working from slides 29 to 35 from the similarity and congruency PowerPoint. So first of all, example 5 is saying to us we have to prove that triangle FEG congruent to triangle HEG if angle F is equal to angle H, so that's noted there with those two little dots, and E1 is equal to E2. So this angle equals this angle there. Okay. So the first thing I'm going to say is in triangle, and I'm just going to state it the way that they've given it to us. Triangle FEG and triangle HEG. Remember, we need three things for three conditions for congruency. So 1, 2, and 3. So the first thing I'm going to say is angle F is equal to angle H. F is equal to H. F is in this triangle, and H is in this triangle. So angle F equals angle H. And why? Because that was given to us. They gave us that information over here. The next thing I'm going to use is the second bit of information that they gave us. Angle E1 equals angle E2. Now E1 lies in the FEG triangle and E2 lies in the HEG triangle. So angle E1 goes under the FEG triangle and angle E2 goes under the HEG triangle. Okay, and the reason for this thing is given. The information was given to us. So let's just have a look, see what we've got here. We've got an angle and we've got an angle. So from those conditions that I showed you yesterday, let's have a look and see what we can use here. So we've got two angles. So we can't use condition 1 and we can't use condition 2 because we've already got two angles. These ones have 3 sides, this one has 2 sides. So maybe we can use this one over here, condition number 3, AAS. So we just need to find a side that is equal. And it's right here, this EG, okay? EG lies in both the triangle FEG and HEG. So here we can say that EG is equal to EG. And the reason for that is it's a common side for both of them. So this is common. And you can see there now we've proved a side. And we've got this condition over here. Okay. So therefore, triangle FEG congruent to triangle HEG. And our reason for this was AAS, angle, angle, side. All right, going on to example 6. So example 6 is saying to us, we have to prove that triangle PMA congruent to triangle PMT, where they've given us that PA, the side PA, is equal to that side PT. They've also given us here that this angle M1 is 90 and this angle M2 is 90. So what I'm looking at with this one here, because this is 90 and that is 90, the side opposite the 90, remember, is your hypotenuse. So the side opposite this 90 is this one. And we know something about that this side is equal to that side. And that side also happens to be the hypotenuse. So what I'm looking at, grade 9s, and this is where the red flags are going up, I'm looking at the condition 4, where we have a right angle, which we do, right angle. We have a hypotenuse is equal, and the 90. So all we need to do then is we just have to prove a side, and we have proved it using RHS, okay? So in triangle PMA and triangle PMT. 1, 2, 3. The first thing I'm going to say is angle M1 equals angle M2. So M1 lies in the PMA triangle. So M1 equals M2. My reason for this, both equal 90 degrees. Okay. The next thing I'm going to say is that this PA is equal to this PT. And PA lies in the PMA triangle. So PA equals PT. And that was given to us. Okay, now the last thing I'm going to prove. So let's just have a look and see what we've got here. We've got a 90 degree or a right angle. So we've got a 90 degree. We've got a hypotenuse. So you see what I've got here. I've got my right angle, 90 degree. I've got my hypotenuse. If I can prove a side, then we've got RHS. And my side is going to come with this PM side. You can see that PM is common with both this PMA triangle and this PMT triangle. So we have PM is equal to PM, and it's common. It's a common side. And that is a side. And what we proved there is RHS. We've got our right angle, 90. We've got our hypotenuse, and we've got our side. So that is condition 4. So therefore, triangle PMA congruent to triangle PMT. And my reason for this is RHS. Right angle, hypotenuse, side. Okay. Going on to example 7. Now, example 7 is a little bit more complex, but it's not too bad. Okay. So what they're saying here is they're saying we have to prove that AB, this, is equal to AD, this one over here. The other information that they've given us is BM is equal to DM, and then we've got a couple of angles here, 153 degrees and 117. Now, the only way that we can prove that AB is equal to AD is if we prove that these two triangles are congruent. Now, you remember what congruent means, that the two triangles are exactly the same. Same angles, same sides, all the same length, okay? So if we prove they're congruent, therefore these two must be equal, okay? So how are we going to go about this? Well, if I can show that this is 90, so this wasn't given to us, okay? If I can prove that that was 90, then I've got that and that is 90. That side is equal to that side, and we have a common side. So therefore, we can prove with one of the conditions, which we'll work out now, okay? So let's try work out what this angle is over here. So what I'm going to do is I'm going to work out angle A1. So A1 will be equal to 180 degrees minus 153 degrees because it's angles on a straight line. Okay, so that gives us A1 is equal to, you can get your calculator. So we've got 180 minus 153, and we get 27. Okay. Then let's work out this M1 angle over here. So M1 will be equal to 180 minus 117. My reason for that, angles on a straight line. So 180 minus 117, and we get 63. Right, now we can work out what angle D is. Angle D would be equal to 180 minus this angle because it's angles in a triangle. So 180 minus 27 minus 63. I'm taking my A1 angle, which is 27, and my M1 angle, which is 63. And let's see what we get there. 180 minus 27 minus 63, and we get 90 degrees. Okay, my reason for this, angles in a triangle. So now we know that this is 90. All right, so now we're ready to prove that these two triangles are congruent. So I'm going to be looking at the ABM triangle and the ADM triangle. So in triangle ABM and triangle ADM, we need three things for congruency. So the first thing I'm going to say is angle B equals angle D. So B lies in the ABM triangle, D lies in the ADM. So we've got angle B equals angle D. Why? Because they're both equal to 90. All right. Now the next thing I'm going to say, they gave us this side over here. This BM side equals this DM side. So BM lies in this triangle. So we've got BM equals DM. And our reason for that was given. All right, so let's see what we've got here. We've got an angle, which is 90 degrees. We've got a side, okay? So what I'm looking at is possibly a RHS condition. So let's just see. We've got to find our hypotenuse now. So there's our 90. So the side opposite the 90 is the hypotenuse. So there's our hypotenuse AM. And there's our 90 there. And the side opposite is this AM again. That's your hypotenuse. And can you see that AM is the same for this triangle ABM and for this triangle ADM? Because it's common. Okay, so we know that AM equals AM. And our reason for that is common. And what we've got there is the hypotenuse. So we have our right angle, we have our side, and we have our hypotenuse. So it's an RHS condition. Therefore, triangle PMN congruent to triangle PMT. And our reason, RHS. Now, grade 9s. Because we've proved that these two triangles are congruent, it must be that AB equals AD. Okay? Therefore, AB must be equal to AD because they're congruent. All right? So our reason is congruent triangles because the two triangles are exactly the same. All right, grade 9s, what I would like you to do now is exercise 12.7, number 4, 6, 9, and 10 for me, please. Thank you.